Recording. Cool. We have started recording, right? Okay. Now let's get started on stages in MapReduce and understand how all of this works, right? So even before we touch upon anything, right? We as discussed earlier, everything in MapReduce environment, right? It happens the key unit of any MapReduce environment is key value pairs. Okay, the key unit of MapReduce computing is k-value pairs. Anytime you want to apply any logic in MapReduce framework, right? Using MapReduce framework, you have to express that particular data in key value pairs. Okay, we will take word count as an example, but this is the basic computing. We have seen here, right, how this one works basically, right? Here I've made a small mistake. It's not this way. I'll tell you. Okay, it's not this way. There is slight difference here. So basically, when we have input that is coming in as text, right? So each line will be treated as one record. Okay. So the offset here, it starts from 0. File offset basically means the memory address. Okay. The memory address of this particular string. Where it starts at 0, the first line, right? And then your sentence. Okay, or sentence 1 or line 1, basically anything is fine. So like that. So let's say you have 10 characters in your first sentence or in the first line. Okay, my second offset starts with this one. This is basically file offset. File offset means like the like the position basically on the disk. So I've just taken an arbitrary number here. Just don't worry about it. It's just a random number. you know Sentence 2, like that. That's how it is. Okay, that's how it is being treated. So let me explain this, right? The first thing that we see here is input. Input here is basically a text file for our word count example, where we are taking n number of lines of text, and we want to convert, or we want to calculate the count of each word that is present here. What MapReduce framework does is it will convert this particular input into it will convert this input into key value pairs. The first one is basically this one, this sentence. What we are going to do is, this is file offset comma, and this is your sentence. Okay, this is how it will convert into key value pairs when it is first reading the text file. Okay, that's how it is done. So in the map phase, what it does is it will pick up each and every word here, and it will assign one. Okay, continuously it will assign ones for each and everything. In the reduce phase, it will take all of this data, and it will reduce and gives the aggregated value. So if the word the or the occurred at multiple places, right? So let's say it will aggregate and give us final result as 54. Dog as 100, if it occurred 100 times across all the nodes, right? Across all the nodes. Okay, so we have discussed about, okay, what is the basic unit. Okay, so general one, right? So suppose you have our trusted old Hadoop cluster, right? Right. Okay, and this is a 4 node cluster basically. So suppose you think you have some input here. Okay, this is your input file. Okay, what happens when this particular your MapReduce, your client with your MapReduce wants to read this data and process it. This is an input text file. Okay, input text file. This contains a lot of data. For suppose, for sake of simplicity, for sake of our discussion, we will take it as a book. Okay, a PDF file or some text file that contains a book. Okay, we have multiple books in one single folder. All of them are in text format, and we want to calculate word count for each of the occurrences of words in all of those books. Let's say we have 100 or 1,000 books. Okay, we have 1,000 books. Okay, all of them are in text format. So when we are, I as a client, I've written a MapReduce program and I've sent it. Okay, I've sent it. I've sent a request to, sorry, my name node, and I've asked the, locations of the data that I want to, read and, process. So my client sends back me the data, the locations of that particular data set, and says that, okay, this is where your, locations are present. Now, what my client does is, right, this is first step and this is second step. So my client directly sends a master copy of my program to all of the nodes that are present. Let's say we have, three nodes that has data. Okay, first node, second node, third node. So all these three has data of all the 1,000 books that are, present, right? So now, how does this data gets read? Okay, how does this data gets read in each of this one? In if you think about it, right, all the data that is present on the nodes, since we are sending our code directly onto these machines, the data will be read on these machines itself. Okay, the data will be read on these machines, but how would we read the data? So that is where we will see the input splitting comes into picture. This is explicitly handled by the framework. We don't have to write any code for it, and we are not responsible for it in any manner whatsoever. But we need to understand what happens. Right? Any doubts here? Okay. Right. So here, what happens is already our data is split across, right? If you think about it. So what we have here is a block of 128 MB for each file present in our nodes, right? And again, if the file exceeds 128 MB, we will be having multiple blocks of the same file in different places, in different nodes, right? When the client sends the code directly to these nodes, what happens is this particular 128 MB block will be read. Okay, this is a physical, this is a physical split of the file, right? The input split is not a physical split. This is a logical split. What do I mean by that? What do I mean by that? Basically, let's say, this particular file, starts from 0, byte to, 128 MB, right? That is the, highest and lowest. Okay. This file has some markers to indicate that, right? So when I say that, okay, when my program, comes here, this framework understands that, okay, I need to read this particular block of 128 MB from this byte to this byte. Okay, this byte to this byte, 0 MB, 0 byte to 128 MB. That's my, like, how many ever bytes are there. Okay, I need to write it. Okay, I need to read it. Since we are handling text files here, okay, since we are handling text files here, we understand that we will have a way to split the files, because in our MapReduce logic, what we will say that, okay, we say that, okay, you will get a lot of text data in blocks. Okay, in blocks, and you need to read each line by line. Okay, and convert this line basically is an English sentence, and we want to convert this into words. So this is what I will give my logic in map, right? So what happens here is basically it will start to read the file from 0 bytes to 128 MB, right? So that's how it starts. And as soon as it starts, it will, like, identify whether we have a new line character or not. New line character is this slash n. Okay, it's not visible to us, but in text files, if you have multiple lines of text present in this file, what happens is, every end of this particular line, we will see this one slash n character present here. Based on this, it will split its input into multiple multiple sentences by this particular input, this particular string. So that's how the input splitting happens. So when map reads this, it reads in parallel. The input is being read in parallel. Each block again will be read in parallel, right? In different machines. So that's how input splitting works, right? So as soon as the data is read, what it will do is it will since we have already given all the map, reduce all of the code directly in one single shot to every node here. What happens is my map phase reads these like this file offset. Okay, file offset. This is an arbitrary number. Just understand that. Okay, and then my sentence. Okay, my sentence into the map phase. Okay, my mapper basically says that, okay, since I got my input here, okay, that's already on my RAM, I'll read it. Okay, I'll read it. And what does map do? Map basically, like, as we discussed earlier, right? Map basically applies a function here, although it's an anonymous function, but applies a function and gets an output in, again, in map type, of map type basically. Map is basically nothing but a key value store. Okay, map is nothing but a key value store. Map is nothing but a key value store. What is a key value store here? Key value store, basically I am saying that, okay, my name, okay, my name is money. A key holds a value or set of values. Okay, like, what are my hobbies? Okay, what are my hobbies? I am money. What are my hobbies? My hobbies is cricket. Okay, my hobbies is reading. My hobbies is so and so. Okay, all of these values. Okay, all of the values here you are seeing, right? This belongs to a certain key. Okay, so that's what all of the phases of MapReduce use basically. So I have a key, I have a value. So I have to, whether I want key or I want value depends on my use case here. Okay. So in our particular use case, what happens is we will not treat our file offset at all. We are interested only in our sentence because we want to count the number of words from this sentence, right? Count number of occurrences of words in the sentence. Okay, words in the sentence. So this is our goal. This is our goal basically, right? So what we will do is in mapper function, when it reads it, when it splits the data, and within the function it applies a split, right? It applies all the split and gets the words from this sentence. Okay, we are not going to bother about the key, right? So that's how the map phase works. Am I clear here?
Yes.
Okay. So, an example, a very small trivial example, how mapper works. Okay. Suppose this is my sentence. Okay. This is my input sentence. This is my input sentence from a line one. Okay. From line one, input line one. So I will split this. Okay. And, create this. This is what my map function does. What is this? This is a full sentence, English sentence. What I have converted it into, I have converted this into a key, that is the word, actual word, and the count. For every word, as soon as we see it in the input, we will just assign one. Why? We don't yet know how many occurrences of word that is present across all the nodes in the cluster, right? So even before we try to calculate anything, what we want to do is we will say, okay, as soon as we encounter a word, and we will say one. Okay, so we will calculate the actual count later on, right? As soon as we encounter this one, we need to do it, and this happens parallelly across all the nodes at once. Okay, every single node in your cluster does this calculation, basically splits your input line and creates a key value pair out of it. which is this is the word, actual word that we are interested in, and this is just a count, right? The count by default is 1. Okay. So here is a pseudocode for it, where what we are doing is we are taking a string key, we are taking a string value. Okay, this is your key. Earlier, we have said that, right? There will be file offset and then the sentence. Okay, string key is your file offset and value. We are interested only in the value. We are not using the key at all here. Okay, but we will take it. We will just, input that as a like a parameter for our function, for our map function. Okay, so we are taking the value for each word w in value. That is this parameter, which is again this one, right? We are saying that okay, right? Basically this there is a split operation that happens here. Okay, the sentence dot split operation that happens here based on a space. Okay, based on space. And we will get words here. Okay, we will get words. Okay, from these words, basically from value or words, we can get each word and assign okay, word comma 1. Emit intermediate means the map is an intermediate phase, it is not the final output, right? So what we are doing is, as soon as our work is done splitting the sentence and giving the word out along with the count, we will like say that okay, my job is done here, take this output to the MapReduce framework. What it does with it, map phase doesn't is not bothered about it. Okay, any doubts here?
So if there are multiple same words in the input, like what will be the output? Like it will be
Same,
hello,
it will just,
true.
like if I have 100 hellos here, right? If I have 100 hellos here, okay, hello comma 1, hello comma 1, hello comma 1.
Okay.
If I have 10,000 world, occurrences of world, I'll say, world comma 1, world comma 1, world comma 1. Okay, like that. I'll have 10,000, different distinct, like, records of world comma 1 in my output from map.
Okay, got it.
Right. Because we don't see why I'm telling you is whatever happens in node 1 is not, node 2 is not aware of that. And node 1 is not aware of what is happening in node 2, right? Because what map is doing is it's a stateless compute. That means there is no like relation as to what is happening here. Like we cannot like say that okay, here I found hello one time. Okay, here I have found hello another time. That means the total count is 2. It is not happening that way, right? Nobody knows, like no mapper knows what's happening with the other mapper, right? So to avoid creating any side effects or anything like that, so suppose I have counted 2 here, but my node 3 is acting up, okay, but it has again hello word. So we will miss the count here, right? If all of these 3 nodes are talking to each other and syncing, right, of the count for one while, let's say for example, instead of just assigning 1, we want to assign the accurate like count of hello 1, hello, the word hello. That means we have to sync and coordinate between these nodes, right? Because hello is a text generic word that can that can be present in any of the like in any of the input that we provide in any of the books, among the 1,000 books, it can happen across any of the book, right? We don't know. So if we were to like really know how many hellos have happened, and we want to coordinate between these nodes, it will be a tedious one. It will be a tedious operation. Like there will be n number of occurrences, and we have to like communicate heavily to sync that. So instead of that, let me just assign value 1. As soon as I find that okay, I have a word, I'll just add 1. Finally, I can aggregate it. At the end, I can aggregate it at once, saying that okay, I have 10,000 occurrences of hello here. So I'll take all of the ones and I will just add it and I'll get okay, hello comma 10,000. That's much easier, right? Am I making sense?
Yes.
Okay. If you still have doubt, we can stay on the topic. I don't mind that. Right. But this is stateless compute. That means we are like no node is bothered about another node. What's happening on the another node? How many occurrences of hello is present on different nodes? It is not bothered about it. All it is doing is in the map phase. Okay, I said okay. It's saying that okay, I have one occurrences of hello here. I'll just assign one. That's about it. In the line 2, I have hello Gemini. Okay, I'll say in the mapper output would be hello comma 1 and Gemini comma 1. Suppose if my input is, I am money. So can you tell me in another mapper, if this is my input, can you tell me what would be the output of the mapper? Anyone?
One for each word. I am and money.
Hmm? Sorry? One
Yeah,
for
like it
each
will be
word.
I one, am
Yeah,
one,
you're
and money
right.
one.
Yeah. So I am comma 1 and money comma, right. Money comma 1. So this happens on every single node for all the input that we are giving. Okay. This happens for every single node in all the nodes in our cluster, basically. Any node that has data that we are expecting to be processed. So this is how it happens with the word count example, basically. Or if you take any different, distinct word, right? Anytime a new word occurs, we will store that in map and say, okay, word comma one, something like that, right? So this is how basically our map works. Okay. Now, there is something that is who handles map? We have to write map. Okay. It is explicitly handled by our user, right? We have to provide a way to, MapReduce framework to know that, okay, this is my data. This is my logic that I want to apply, and this is the output that I want to get out of it. Okay. This is our, job, right? So what happens after map? What happens after map? Okay. What happens after map is very interesting, right? Since we have been calculating all of this data, sorry, calculating all of this once, right? What happens is we have data distributed across multiple machines on a node, right? That means that no sing we have data that might not fit on the RAM of each machine on these individual nodes, because we are splitting and we are assigning tuples, right? This consumes some amount of RAM. And if you have gigabytes and gigabytes of data on a single RAM that we are processing, it is not able to store all of this data in one single node. That means all of the key value pairs that we are generating in map phase, that we might not be able to store it in on the RAM, for the map, reduce phase to pick up later on. And we also established a point, right, where we know we are using commodity hardware for all of this, right? That's the whole, deal with the whole Hadoop cluster thing, or on-premise systems where the reliability is not much. We might expect machine failures as well. If something happens and one of the node goes down, we need to recalculate the whole thing again and again. Okay. And in production systems, the logic will not be this simple. Again, it takes a lot of time, is what I'm trying to say. So what the MapReduce framework does is that, to avoid all of this, headaches, it will just say that, okay, I'll write to disk. As soon as we are, getting, let's say I have, 1 terabyte RAM. As soon as my 80% of, 1 terabyte RAM. Now, as soon as 80% of this, gets filled up, I'll, dump, this to a disk. Okay, like that, I'll dump all of my intermediate output of map to the disk of this particular machine. Every single machine dumps the data to its disk, where it is durable. Even if there is restarts, there is some issue with the map output, we can always, get the data from the disk, right? So that is one thing, right? So the next phase is, handled by framework, again, MapReduce framework, that is shuffle phase. So what shuffle does is that, let me give you some context here. If you have four node cluster, right? Not every single node will be a mapper node. Okay. We will run our map on, like X percentage or in 90-95 percentage of nodes, so that our job is running in parallel, but we will reserve one or two nodes in our cluster to reduce job. Okay. Reduce is a different operation where it aggregates the data, right? So it doesn't require, a lot of, parallelization here, or the nature of job doesn't require a lot of parallelization. If you have, multiple nodes that runs reduce, that is fine. But if but most probably reduce will be, like if the job is, slightly smaller, it doesn't, deal with a lot of data, we will just use but one reduce and then we are good, right? But the reduce framework, needs data in certain format, right? I'll explain why. So if we are sending all, like if you want to like aggregate all of this data, right? We can send all of the output of, this, key value pairs, that is, word comma count, that is one, to one single node and say that, okay, anytime there is word one, I want to like, add up and, give the final count, right? That is word one comma n1. That is my final count here. Right. So what we do is we will assign one node as reducer node, and we will, before we do like, send data, we will sort it and we will shuffle it. Shuffle, or, copying data to reducer node. This is what this phase is called. Shuffle basically means copy, copying over network. Okay. Shuffle basically means copying over network. Okay. That's what we are doing with the reduce phase. The whole reduce phase starts with the output of mapper phase, which is both sorted and, transferred to reducer. Okay. This is a sorted output. Okay. So before we sort it, what we do is we will, like convert into a slightly different format. Okay. Slightly different. Instead of, we having, 10,000, different entries, what we will do is we will merge them and make it into one entry. Let's say I have, like this, right? I have, sorry, I have, like, hello 1,000 times, or, three times here in this example. What I will do is after, shuffle and sort, my input to reducer, becomes like this. Okay. I'll have one, hello, and I have, all the counts that are present here. One, 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 one. We'll have, 1,000 entries like this, or 10,000 entries like this. If we have this, let's say world is, I have 500 occurrences. We'll have one, 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 one like that, in 500, like, 500 ones in one single list, like that. Right. So this is how shuffle and sort works. Why we need to shuffle? Because map runs in very like, parallel manner, and, it just creates n values for n inputs, right? Reduce doesn't work that way. Reduce, basically literally reduces the amount of input to one single value per key, one single value per key. So in order to do that, we need to like, transfer the data out of each of the mapper to one single reducer, or, like n, multiple, like multiple reducers to calculate and aggregate over and, generate one single output per key. So that's how reducer phase works. Okay. Right. So here is an example here, right? So when reduce, takes the input from, the, shuffle and sort phase, right? Or sort and shuffle phase, right? So this is what our, reducer gets. Okay, R1 gets, this is the reducer 2 gets, and this is reducer 3 gets. The output would be this. Okay, the final output. The final output would be this. Okay, I can say that, okay, in all of the documents that I received, hello occurred three times, world occurred two times, and Gemini occurred only once. So this is my final output. This is my final output, right? So this is how reduce works. Okay. So we will see a pseudocode for this one. Give me a second. Yeah. So what basically reduce does is it takes two values. One is key and one is iterator values. Iterator is nothing but a list here. Iterator can be anything like list or a tuple or bunch of values in one single variable. That is basically an iterator, right? So what we does is for every single key, we will get the counter here and we will say that okay, okay, right? We will have the result and we will parse this iterator values as ints and we will just add them to our result. Okay, that's how it is. Basically this will what we are doing is, yeah, this each and every single input here in the iterator in this particular list will be added and finally we will get 3. This is our output, okay, which is what we are seeing here, right? So okay, any doubts till here? Okay, cool. Right. I guess I'll get started. Okay, I guess I'll start ahead with this. Right. So generally, if our data is very low, what we will do is we will have only one single reducer. Okay, and then aggregate the data at one single place, and then we will get one output file. Right. If we have multiple reducers, right, which means that we have to have some sort of logic here to finally get the data out. Okay, why we want to have multiple reducers? Okay, if the data is less, one reducer can take it, right? But if the data is like lot more, than what is the capacity of RAM on this one, because that's how when we read the data from the shuffle and sort phase, it has to be read into the this one reducer and it will directly go into RAM.
Hi,
Okay.
Ansika.
Hey, hi Shashikant, can you be on mute? Sorry. Hey Shashikant, you're on. Okay. If you're talking, can you be on mute? Yeah.
Sorry, Mani. I joined
No.
late. And
Yeah, no issues. Yeah. So like when we are reading the shuffle data from shuffle and sort phase into reducer, it directly goes to the RAM of that reducer, right? When the data itself is exceeding the capacity of reducer, which can be very easy to do because we are dealing with lots and lots and lots of data from multiple machines running parallelly, and then every single mapper pushing data towards one single reducer, it can definitely lead to memory issues, right? So what we can do is we can have multiple reducers here. How do we coordinate between them? What data gets sent where, right? This is a challenge now. This is the challenge now. So in a crude way, what we can do is we can say that okay, you know, the amount of words between A and M and N and Z are same or more or less same, right? What I will do is I'll provide a logic in my shuffle and sort phase saying that okay, this is my partition key where you are inputting the words from A and M to reducer 1 and the words N to Z to reducer 2. Okay, this is my crude logic basically, right? The final output instead of one file, since we have two reducer files, will be two output files, like two output files that are that will be outputted from reducer. So these files will be stored in our hdfs. Okay, whatever the files that are intermediate files that is received from shuffle and sort, or the intermediate mapper output, that is stored on the internal hard disk of the nodes. Okay, hard disk or ssds of the nodes. Okay, ssds of the nodes, that's where this intermediate output will be stored. Okay, that's where this intermediate output will be stored. But the final reducer output will be stored in your HDFS in a location, HDFS location basically. Okay, so the number of files on your reducer right? The number of output files from your reduce phase will be determined by the number of, reducer machines on your desktop. Okay. Any doubts here? Don't worry if you find, little, going off, over your head. I'll explain all of this, again, with the diagrams and all of that. But I'm just giving you all the, heads up with all the topics that we are going to again revisit, basically. Okay. Right. Sometimes, right? Sometimes the jobs can only be map only jobs. What do I mean by that? What do I mean by that? Let's say I want to just filter the data. Okay. Just filter the data. Just filter the input data. So in the books that I have, I've gotten out of 1,000 books, let's say, based on the title, I can see only 900 books are good for processing the data. Rest of 100 books are maybe, let's say, AI generated, or those are not the area for focus, basically, right? So what we do is we will just, use a map only job prior to our our word count example. We will use another map job, and we will say that, okay, filter out all of these, novels or books that are not, you know that are not needed for us. So that can be map only job, basically, right? Because the data is spread across all these nodes, we can just say that, okay, go to each node and say that, okay, we don't want this data, and we will, get the data out, from that particular phase, map phase, and we will write it to new location. Our word count, right, that can pick from that location. So what do I mean by that is, right, when we are reading from the input location, right, the map only job can, in fact, read this, data, the input data, and, it can just output these, filtered, files. Okay, filtered files to a different location, okay. And this can be picked up, for our, word count analysis, our word count program, right? So this is a map only job. It doesn't require any a reduce phase or anything like that. Even transformations, let's say you want to clean the data, right? This doesn't require any reduce phase, right? So that's how it is. The map output is the final output here, right? Okay. So this is basically the diagram of all the phases that a single map reduce job has. We read a file, we map the input and, split it. We write the intermediate output of the map phase, right, to a disk. Again, shuffle and sort happens. Again, it will write to disk. That will be read by the, I think I've repeated it. That will be read by your reduce phase, and the final output will be returned to HDFS, right? The disk here means the disk of, you know, data nodes. Okay, that's what it is. Right. This is not visible to the disk is not visible to your HDFS. Okay. This is not visible to HDFS, basically. Okay. Any doubts here?
So where does the shuffle phase happen in the same node as the mapping node?
Sorry?
So the shuffle phase, does it have some dedicated nodes again, or does it also
No, no,
happen
no,
on
no. It
the
happens
node?
in map. It happens in map nodes. Okay. Generally, what happens is if you have scarcity of nodes, or, scarcity of resources, the same node that runs the map job can be assigned as a reducer.
Okay.
Okay. Yeah, and yeah, that's how it can be done. So what happens with the map, phase is, if you want to, parallelly process the data, right? We can just, take up all the resources on the node, and then, it will really create issues. So what we will do is we will say that, okay, for this job, let's use only like 20% of the nodes for map, okay, and maybe less than 1% of the nodes for reduce phase, and it will, not put your job at jeopardy, because you have multiple copies of the same, blocks across, spread across different nodes, right? Like we discussed in HDFS, right? So the same block can be available in multiple machines. So when the framework is, scheduling any MapReduce job, right, it is intelligent and it is aware of all of these, nodes being spread across, multiple machines for the same file. So for the same, file, if we have, two blocks available in one machine, it will just say that, okay, process these, both of these blocks on the same machine. We don't have to, like, move ahead and, like, find it in another machine. So it is very intelligent in that aspect.
Okay. And what does this mean? Like HDFS doesn't know about the disk of data nodes. Like the data
Okay,
is stored in the disk itself, right?
right. So HDFS is a distributed file system, right?
Yeah.
That means whenever I'm running, like, say, ls command, HDFS, DFS ls command, it means that, the data is spread across all of these nodes, and I have to get that, right?
Yeah.
Right. This individual node is again a Linux box, normal Linux box. Okay, there is a shared space. Uh, okay, there is a virtual, not shared space, but there is a virtual, shared, like, there is a virtual, arrangement of, resources between, how much your HDFS needs for its operations and how much your, like, normal Linux box works, right? This Linux box doesn't do anything, right? It just stores the data. It has some disk, it stores the data, and whatever the command that the, HDFS name node, provides, it will run these commands and it will, like, do the data. This HDFS one, whatever that we are seeing, it's a shared space that is present across all these nodes, right? Right. It also utilizes your disk. It doesn't, like, go ahead and, have a separate disk or separate resources for HDFS. It also says, but for your normal Linux operations, like, just querying, some files on this data, on this node, right? It doesn't refer to your HDFS's shared space. Okay. This has a different, workspace or different, space compared to your, Linux one. So your Linux is normal, box which, has your CPU, RAM, and all of that. CPU, RAM, hard disk, and all of that, right?
Yeah.
This one, this is your normal file system. Suppose you want to attach a distributed file system to it. What happens is it will create a, separate abstraction layer on top of all of these resources and says that, okay, when you are querying anything on this system, I'll only display my results for this system. Okay. But when you are querying it through your HDFS, I will virtualize this and I will, give you the results through, this one, the commands that is entertained through name node. Am I making sense? So when a
Yeah.
mapper job, runs on it, right, it will store the data on this particular Linux server because it is stateless compute, right? None of the other nodes, is bothered about the output of this one, right? That's why it is storing on this, intermediate phase,
Yeah.
which is not available for this one. Clearly, HDFS doesn't, is not bothered about this, like, intermediate, output of this particular map phase.
Okay. So, but the final output is stored again in the.
HDFS, yes. So here the file is read from HDFS, the final file is, written to HDFS. But all of the intermediate steps, output is written to your disk of this particular Linux box, basically. It's not written in your shared, file system called HDFS.
Okay.
That's a great question, man. Awesome, awesome. I like this. Yeah. Any doubts? Any doubts? Right. So now what happens, when we are reading the data, right? So when we are reading the data, right, what we have discussed about input split and all of that, right? So input split is just a pointer. It's just a virtual pointer. It is not a physical, anything, a physical file or physical representation of anything. It just says that okay, I have a file here. Let me read from byte 0 to byte 6. 67 million. 108,000. 864 bytes. Right. This is the pointer. This is the pointer. Your input split is the pointer. Right. Before the map actually gets the data, what happens is it relies on something called as a record reader. Right. So the whatever the input split is giving this record reader to read, it will read it and it will convert into key value pairs. So basically a record here means, right, a sentence from the text file. Okay. So that's how the record, read. Suppose I have a text file saying that, okay, hello world. Okay. Hello Gemini. So this is these two are completely different lines. So when record reader tries to read this file, it will understand that okay, I have to read from zeroth byte to 67,000 sorry 67 million 108,864 bytes. Right, that is the end of the file here. So while reading it, what it does is okay, this is what we are getting from input split, right? This is what we have to read. So what record reader does is okay, as soon as it encounters this new line character, right, slash n, after each of these lines, it will turn this into key value pairs. Okay, key value pairs. Okay, so that is how this particular thing works. This is how the map phase will get the input when it is reading the data from the disk or HDFS basically, not disk, HDFS. Okay. For the map phase though, as I have explained, we are interested in only one value. Sorry, if we are interested in only the value. This one is basically byte offset or file. This one. That means this is a random gibberish number. That is represented. That is representing the memory address of that particular value. Or this is basically our sentence. Okay. So that's how record reader works. So what if our input is split in the middle of the sentence? Let's say, I have, two blocks here, right? This is HDFS blocks. Okay, this is block one and this is block two, right? So I'm continuing a sentence and my sentence is abruptly ended because we have 128 MB chunks, right, of HDFS files. So this is again 128 MB. So this block, right, and this block share the same sentence because HDFS is dumb. It doesn't understand whether it is at the middle of the sentence or the middle of the record or something like that. It will just chop up the records by 128 MB. Since this is a raw text file, it doesn't have any distinction. But if you have some like parquet file or something like that, that's a different case. But this is a raw text file, right? This is a raw text file. So again, this is a text file. Okay, this is a raw text file. So it doesn't have any idea where it is splitting. So what happens then? Right? What happens then? So this is where MapReduce framework shines. So it is little intelligent about it. So for every single row, it expects a new line character, right? That's how record reader works. So here we don't see the record new line character here, right? We don't see the new line character here. That means the record reader one, the first record reader one that is running in one node understands that okay, this record is not complete. It will not stop reading the record. It will try to understand that okay, my block 2 which starts from the offset, okay, this starts from this 0th offset to 68 million whatever, right? And my next block starts from this particular address like 68 million whatever. Okay. So it will go to block 2. It will not stop here. It will go to block 2, right? and it will pick this up in this particular record. Okay, block 2 in the, like data node 2 will be sending the rest of the record that is present here to data node 1. Okay, data node 1, this is the only time they are communicating between the nodes. Okay, right. So how does record reader 2 happens? Since this is not starting from 0th block, sorry, 0th offset, or or the starting of the file, it knows for a fact that okay, I will not read the first line here. I will not read the first line here, which has slash n character here. I will not read the first line here because usually it means that this is coming from, this is split across the previous block and this block. It will not read it. It will not read it. Okay, your Hadoop, framework is sorry, MapReduce framework is little intelligent about that. So it will not read it. It will just pass up. So that's how we will avoid reading the same data or the same record in across both files in a duplicate manner, right? So this is how it is. This is how it works. So when we have record split across multiple files or multiple blocks. Okay. Any doubts here? This is an interesting edge case, by the way. This is a very interesting edge case if you think about it, right? It can happen, right? Like we can see that the text file which has which exceeds like 128 MB. It the HDFS doesn't really care whether it's the middle of the sentence or end of the sentence. It will just chop up and it will say that okay, this is my 128 MB block and I'm fine with it. But while processing the data, it will get tricky. We will have data like double reads and all of that, which is very bad, right? Which is not good at all, right? Okay. Let's call it a day. We will have, maybe I'll have another session planned for tomorrow. I have just written notes. I'll share details if I'm going to have a session tomorrow. It might happen in the evening, or I'll see how it happens. But yeah, let's call it a day for today, and we will again meet tomorrow. I'll stop the recording now.